A new era of precision. By the mid-19th century, the age of giant, heroic telescopes like Herschel's and the Leviathan had captured imaginations. But something new was brewing. Astronomers were no longer satisfied with just seeing the heavens. They wanted to record, measure, and decode the light of the stars. This was the birth of astrophysics. The telescope was about to evolve beyond an optical extension of the eye. With the rise of photography, spectroscopy, and electricity, telescopes became scientific laboratories, not just magnifying tools. Observatories grew into institutions, engineers joined astronomers, and the universe itself began to reveal secrets that had been hidden for billions of years. The rise of observatory giants. Yerkes Observatory, the last great refractor. In 1897, in Wisconsin, the Yerkes Observatory unveiled the largest refracting telescope ever built, a 40-inch lens monster. Constructed by Alvan Clark and Sons, the leading lens makers of the era, this telescope marked the high point of refractor design. The Yerkes refractor was a marvel. Its giant glass lenses weighed hundreds of pounds, and the observatory's dome had to be specially designed to house the behemoth. When first light passed through its pristine optics, it delivered views that were breathtakingly sharp. But Yerkes was also the end of an era. Refractors simply couldn't get bigger than this. Large glass lenses sag under their own weight, creating distortions. Beyond 40 inches, refractors were impractical. The future clearly belonged to reflectors with their lighter, scalable mirrors. Lick Observatory, a mountain vision before Yerkes, another giant, had already claimed the skies. The Lick Observatory in California, completed in 1888. Funded by James Lick, a piano maker turned wealthy philanthropist, the observatory was perched on Mount Hamilton, a bold choice at the time. This was one of the first major observatories deliberately placed on a mountain, taking advantage of thinner atmosphere and less light pollution. The 36-inch refractor at Lick revealed stunning detail and helped push astronomy into the modern age. Humorously, James Lick originally wanted his fortune spent on building a giant pyramid in San Francisco with his name on it. Luckily for science, advisors convinced him a world-class observatory would be a better legacy. Imagine the alternate history. A giant California pyramid instead of one of the greatest observatories of the 19th century. Photography meets astronomy, daguerreotypes of the stars. Until the mid-1800s, astronomers had to rely on hand-drawn sketches of what they saw. As you can imagine, results varied wildly. One person's fuzzy patch could be another's detailed spiral. Then came photography. In 1840, John William Draper managed to take a daguerreotype photograph of the moon. Soon, astronomers realized cameras could record what eyes could not. Long exposures revealed faint stars and nebulae invisible even through the telescope. By the late 19th century, observatories were mounting glass photographic plates directly onto telescopes. These plates could capture hours of exposure, stacking faint star light into crisp, permanent images. For the first time, astronomy became objective and reproducible. The Harvard Plate Collection, one of the most famous examples, is the Harvard College Observatory Plate Collection. Beginning in the 1880s, astronomers photographed the sky systematically, creating a photographic map of the heavens. Today, the collection includes over 500,000 glass plates, recording the sky for more than a century. What's incredible is that these old plates are still scientifically useful. Modern astronomers use them to study changes in variable stars, supernovae, and even black hole outbursts. It's like having a cosmic time machine stored in dusty cabinets. Spectroscopy, reading the stars' secrets. While photography captured what stars looked like, spectroscopy revealed what they were made of. By passing starlight through a prism, astronomers could split it into a rainbow spectrum. Dark absorption lines revealed chemical fingerprints, hydrogen, helium, sodium, and more. In 1814, Joseph von Fraunhofer had mapped these lines in the sun's spectrum. But it was in the 19th century that astronomers realized these lines were universal. The stars weren't mysterious glowing dots, they were suns composed of the same elements as Earth. This was revolutionary. The telescope was no longer just showing us where objects were, it was explaining what they were. The field of astrophysics was born. Women astronomers at Harvard, often called the Harvard computers, played a vital role in this era. Annie Jump Cannon developed the spectral classification system OBAFCM still used today, and Cecilia Payne-Gaposchkin later demonstrated that hydrogen is the primary element in stars. Without their painstaking analysis of spectra, modern stellar astronomy wouldn't exist. The Hale telescope's reflectors rise, Mount Wilson, the 100-inch Hooker telescope. By the early 20th century, mirrors had firmly taken over. In 1917, the Hooker telescope at Mount Wilson Observatory in California went into operation. With a 100-inch, 2.5-meter mirror, it was the largest in the world. This telescope made history. In the 1920s, Edwin Hubble used it to prove that the spiral nebulae were actually galaxies far outside the Milky Way. Suddenly, the universe was vastly bigger than anyone had imagined. He also discovered the expansion of the universe itself, laying the groundwork for the Big Bang Theory. Imagine that one telescope, perched above Los Angeles, changed humanity's view of the cosmos forever. Palomar, the 200-inch giant, but astronomers weren't done. In 1948, the Hale telescope at Mount Palomar came online with a 200-inch, 5.1-meter mirror. It was the ultimate reflector of its time, requiring decades of work to cast and polish its giant glass mirror. The Palomar telescope dominated astronomy for the second half of the 20th century, uncovering quasars, refining galaxy studies, and pushing the frontier of the observable universe. It became the poster child of big science, inspiring a generation of astronomers. The birth of radio astronomy. While optical telescopes were getting bigger, a new kind of telescope quietly emerged: radio telescopes. In the 1930s, Carl Jansky, an engineer at Bell Labs, stumbled on strange radio static coming from the Milky Way. At first, his bosses weren't interested. Radio astronomy wasn't even a field yet, but his discovery opened a whole new window on the universe. Soon, pioneers like Grote Reber built dish antennas in their backyards to map the sky in radio waves. Reber's 9-meter dish, built in 1937, was the first real radio telescope. It looked more like a giant satellite dish than a telescope, but it worked, revealing cosmic radio sources invisible to optical telescopes. By mid-20th century, radio astronomy exploded. Giant arrays like Jodrell Bank in the UK and the Very Large Array in New Mexico picked up pulsars, quasars, and the afterglow of the Big Bang. Telescopes were no longer limited to visible light. Humanity was listening to the universe itself. Humor and human struggles. This era wasn't all triumphs. Casting giant glass mirrors was notoriously difficult. The 200-inch Palomar mirror cracked during its first attempt, and it took months to cool the second casting without breaking. Imagine babysitting a bathtub-sized block of molten glass for weeks. Astronomers also wrestled with early radio telescopes that picked up interference from passing cars, household appliances, or even pigeons. In fact, one Nobel Prize discovery, the cosmic microwave background radiation, was almost dismissed as pigeon droppings on the antenna. It's a reminder that even the greatest scientific revolutions sometimes hinge on very down-to-earth problems. The universe expands. By the early 20th century, telescopes had evolved from fragile tubes of glass and wood into industrial marvels of steel, glass, and electronics. Photography and spectroscopy turned astronomy into astrophysics. Giant reflectors revealed galaxies beyond number. Radio telescopes opened invisible worlds of pulsars and quasars. Most importantly, this was the era when humanity truly realized the universe is far bigger, older, and stranger than we ever imagined. The telescopes of this period didn't just show us more stars, they expanded reality itself.
And that's the end of part 4 in our epic story of telescopes. We've moved from the majestic glass refractors of the 19th century, like the Yerkes and Lick observatories, to the powerful reflectors that opened the 20th century, and finally into an entirely new frontier: radio astronomy. This was the age when astronomy transformed from simply looking at the stars into something much deeper, analyzing, recording, and decoding them. Telescopes were no longer just magnifying glasses for the night sky. They became full-fledged laboratories. With photography, we could freeze starlight onto glass plates and create a permanent cosmic memory. With spectroscopy, we learned that the stars weren't mysterious points of light but blazing furnaces made of hydrogen and helium. Suddenly, the universe felt both familiar and unimaginably vast. And then came the giants. The 100-inch Hooker telescope at Mount Wilson showed us that the Milky Way was not the whole universe, it was just one galaxy among billions. Think about that. A single telescope, sitting on a California mountaintop, multiplied the size of the known universe. Then the 200-inch Hale telescope at Palomar pushed even further, showing us quasars and the farthest galaxies we had ever seen. But perhaps the most dramatic twist was the quiet birth of radio astronomy. At first, it wasn't even astronomers making the discoveries, it was engineers like Karl Jansky chasing down mysterious static. Out of those humble beginnings came a whole new way of exploring the cosmos. For the first time, we weren't limited to visible light. We could listen to the universe, tuning into pulsars ticking like celestial clocks, quasars roaring with energy, and the faint whisper of the Big Bang itself. This chapter in telescope history was about expansion of technology, of ambition, and of imagination. Telescopes got bigger, sharper, and more precise. Astronomy turned into astrophysics, and humanity's mental map of the cosmos stretched from a single galaxy to an unthinkably vast universe filled with billions upon billions of galaxies. But we're not done yet. The story only gets more exciting from here. In part 5, we leave the mountaintops behind and head for the skies, literally. We'll look at the age of space telescopes, Hubble, Chandra, Spitzer, and of course, the James Webb Space Telescope. We'll see how adaptive optics, interferometry, and cutting-edge engineering let us peer deeper into the universe than ever before. And we'll talk about the future of telescopes, giant observatories under construction now that promise to change astronomy all over again. So, if you've been blown away by how far we've come in just a few centuries, from Galileo's spyglass to Palomar's 200-inch mirror and Jansky's radio antenna, just wait until you see what comes next. Humanity's greatest telescopes are not behind us. They're ahead of us. Stay tuned, because part 4 is going to take us straight to the edge of the universe.